Yeah, good evening, everyone. Can anyone confirm if I am audible in the chat box?
Yes, sir.
Okay. I hope the screen is visible to everyone. So I welcome you all to the NPTEL live session for the first week on the course Integrated Waste Management for a Smart City. I am Abhishek Raj, PMRF scholar in the Department of Civil Engineering, IIT Madras. So this session will happen every Saturday, 5 to 6 p.m. In addition to this, there will be another session on Friday that will be from 6 to 7 p.m. So you can attend any one of the sessions or even both as per your convenience. So we'll start with the session. The main intention of the session would be to give you an practice of the assignments and an overview of the previous week so that this will help you in solving the problems of the assignment which are being given in the course. So we'll start with the overview for the first week. So firstly, we have the lecture one. So this includes so the first lecture was concerned with the methods of waste management, that is the traditional methods. So here we talked about incineration, the normal dumping that we see, and then we had the second method that was landfill. So these are the methods that are traditionally used for waste management. So this was the first lecture. Then we have the history of solid waste. So in medieval times, there was no predefined method for waste management. So it used to lead to several problems such as disease, odor, litter. So the second lecture was concerned with the introduction of landfills, a basic introduction. Then we saw the elements of waste management system. So this included the six elements. So it had collection, generation. Then we try to separate the waste. Multiple kinds of separation are there. So we can separate at the source also, and we can separate properly in a facility. So after separation, we have transport of the waste. Then the waste is collected. It can be processed. So there is the processing stage. Finally, we will have the disposal stage. So based on the city, one or two of these stages can be absent also. So these are the six elements that will usually be there. So in lecture three, there was the global scenario for solid waste management. So Europe is quite ahead. We talk about a global scenario. So Europe is doing very well in terms of solid waste management. Most of their waste gets recycled or incinerated. So they are managing it pretty well. Then we have waste as a resource. So presently or traditionally, we have adopted the cradle to grave approach. So we mine for a material. We use the material to form a product. So, and once the product is discarded, the material goes to waste. So instead of doing this, once the product has become a waste, we should try to recover the efficient or the material which is still good. We can prevent the mining stage from happening. So we can save material in this way. So instead of cradle to grave approach, there is a need to adopt to cradle approach. So lecture four it was about source reduction and recycling and waste to energy. So waste to energy, we have heat, energy. There can also be combination of both these. The last lecture was concerned with landfills, different types, issues, and regulations. Then we had the leachate collection. what are the elements of a leachate collection system, such as liners, geometry. So now we will see the questions. So there are around 15 questions, and we'll see them one by one. A few of the questions we will do as polls. So you can answer them in the poll section. I'll drop it there. So coming to the first question. So which of the following is the de facto choice for waste management? So the options are composting, incineration, landfill, and recycling. So when we talk about waste management, as I told before, uh, there are traditional techniques which are being used. So there is incineration, we will have dumping, and we will have landfill. There are other waste management tools also, but namely these three only will be used traditionally. So whenever if we talk about the de facto choice, so it will always be de facto means default. For people who don't know, I'll just say. So the traditional choice will always be landfill because landfill can manage different kinds of wastes. In case of incineration, there will be different, mostly organic wastes which can be easily burned. Only incineration is suitable for them only, and dumping has its disadvantages, odor, litter, other things can happen. But landfill, a proper engineered landfill can help eliminate the waste problem up to certain extent. Although it is not very desirable, landfill also, but for a default method, whenever we want to go, we will always choose a landfill. Now, other suitable techniques have come up like recycling and the 3Rs. We'll see them one day. So, de facto choice will be landfill. That is option C. Untitled Chapter. So we'll see the solution. So it was option C, landfill. So you can refer to whenever I write this W hash L hash, it means week one, lecture one, or whatever the number is here accordingly. So please remember this notation. I'll use it throughout the course. So when I write, say, week three, L5, so it means third week, lecture five. Just to add a reference to the slides so that you can refer back. So this is taken from the slides of the course. So here it is written, landfills are the de facto choice for waste management. So they cause a lot of problems, land usage, air, surface water, groundwater contamination can also happen if not properly managed. So leachate production is there, methane production is done usually, and it can be used for energy generation later. So and later is also a big problem. Default case, we will always go for landfill. So we'll see the second question now. So according to the Environmental Protection Agency, percent of waste quantity can be reduced with source reduction in solid waste management. So you need to tell what will be the percentage that can be reduced. So the given options are 100, 15, 10, and 15. So what EPA guidelines say that if we are doing source reduction, so up to 50% of the waste we can reduce. So the waste that is being generated, let's say present generation of waste is X kgs from a locality, so it can be reduced to 0.5x if proper source reduction is done. So the answer for this is option D, that is 15. So we'll see this. It is from week 1, lecture 4. So EPA estimates that 50% of the waste quantity can be reduced with source reduction. And it should not be a substitute of one problem for another. Like say we are using steel for manufacturing some product, and that product is becoming as a waste. Just example I'm giving. So now what we do is we try to reduce the steel. Let's say we reduce the steel by 50%. So we reduce the steel, and instead of the steel, now we started using aluminium. So that is not the solution for this problem because we reduced the steel, but now we added aluminium to the waste. So it should not happen like this. We should try to properly reduce it rather than substituting it. So also packaging is 50% of the waste volume and around one third of the weight. So we can reduce packaging. That also will help in just admit. Let's go to. Yeah, we'll take the doubts. We'll take the doubts. Can't take it after every question. So we'll take it like after every 10-15 minutes. So please wait. So we have paper and plastics that is used for packaging. We also spend more on food packaging than farmers net income. These are the examples I gave. So refer to the lectures for more details. Coming to the third question. So this is a poll. So this is a match the following question. So you can see. So it is disposal, transformation of waste and waste minimization on the left side. On the right side we have incineration and composting, using optimum resources and energy, and the least favored method of solid waste management. So the given options you can see here. So just drop a poll and you can answer it. It's question 3. I hope you can see the options A, B, C. So the poll is live. You can answer in the poll, and also if anyone has any doubts, you can type in now. So I have put a poll for question 3. You can answer it. Anyone has any doubts, you can ask now. Uh, if you are writing the answers in chat, just write it like 3C, 4D, something like this, so that I will be able to distinguish which question you are answering. Yeah. So we'll see the solution now. Firstly, we have disposal. So we'll take it one by one. Okay. Let's not get confused by the mass performance. So we'll take it one by one. So we have disposal. So I don't know how many of you will remember, but sir showed us pyramid. So firstly, the most preferred is reuse, where we try to reuse the materials that we have been using, and the least preferred is the bottom part, that is disposal. So disposal can be matched with C. So one will go with C. So we will have options B and option D for it. So we'll need to match one more and we'll get the correct answer. So we have transformation of waste. And also we have waste minimization. So waiting. So now we have transformation of waste. So transformation, how do we do? We have a waste. Okay, so we want to get something useful out of it. So we can do incineration. So incineration will give us heat and energy, both it can give. And if we do composting, so incineration you can do for mostly organic waste, and composting also will happen for biodegradable waste. So composting will give us compost that is used for agricultural purpose. So transformation will get matched with A, that is incineration and composting. Thirdly, we have waste minimization. So that would go with B. So using optimum resources and energy. So that is like waste minimization we should do, but it should happen using optimum resources and energy. So excess energy should not be used, otherwise that also is a disadvantage. So we'll go with 1C, 2A, and 3B. So option B will be the correct answer. So coming to the answer, it was option B. You can refer to week 1, lecture 2. So you can see here, so we have the disposal stage. So that is the least favored. And if we talk about the elements in the waste management system, so the fourth element is separation, processing, and transformation. So here we have incineration and composting, which are considered as transformation of the waste because we are trying to convert the waste into a useful form. Coming to the next question. So the liquid waste that forms in a landfill when water passes through is called. The given options are concentrate, leachate, seepage, and none of the above. So taking the example of a landfill here. So let's say this is a landfill. Let's say it is a non-engineered landfill. Okay, so any liner or anything is not there. So what happens is, so the landfill will have certain moisture, inherent moisture of its own, and also when rain or even some storm comes, so water will seep inside. So along with the water, the content, the organic content or the inorganic content, chemicals, different things, they will seep through this water and they will go and get collected in the uh, crevices in the ground, or it can even reach up to the groundwater level. So this process where the water percolates through the landfill, it is called leaching. So you would have heard this term before. It is called as leaching, and this the liquid that percolates, that is called as leachate. So the percolation process of the water through the landfill, where it absorbs the different components and it will become like a polluted, highly concentrated and polluted liquid. So that is called as leachate, and the process is called as leaching. So that will be found when water passes through. So the option will be B, is leaching. So we'll see the answer. So it is option B, leachate. You can refer to next week lecture 5. So leachate is the liquid that forms when water, that is rainfall, groundwater, travels through the solid waste. And leachate can migrate into underlying groundwater. The leachate can contain many different chemicals, and so these different chemicals will depend upon the composition of the waste. So depending upon what is there in the solid waste, the leachate composition can change. See the next question, question 5. What is the primary advantage of using a liner in the landfill? So the given options are prevent seepage into underground layers, improves the efficiency of degradation, prevents odorous gases, and none of the other. So this question is linked to the previous question. So as we saw, we had landfill that is used for waste management. So when rainfall falls on this and seepage will happen through the landfill, so leachate will get formed. So we don't want this leachate to reach the bottommost layer. So bottommost layer we refer to as groundwater. So we don't want the groundwater to get contaminated. So how do we prevent this? So we'll place a layer here. So this layer should be, its K value, that is the permeability value, should be very less. It should be less than 10 to the power minus 7 centimeter per second. So this would prevent the entry of leachate into lower levels of soil or groundwater. So different components are used, such as we use compacted clay. We also use geomembranes, and nowadays composites have also come, which combine both of them. And some polymeric materials have also come, which are emerging now. Foreign countries are using them. So what is the primary advantage of using the liner? So it prevents seepage into underground layers. We can add of groundwater. We don't care if it contaminates the soil that much, because if it is a landfill, no one is going to use the soil there. But if it contaminates the groundwater, that can affect. So that would be prevents seepage into underground layers. And also, if some time ahead in the future, if the landfill is used for a different purpose, even the soil contamination will come into it. The answer for this is option A. So it prevents the seepage into underground layers. So that is week 1, lecture 5, you can refer. So these are low permeability barrier layers we use clay, plastic, and composites. So the liner keeps leachate from migrating out of the landfill, and the leachate must be collected and removed. So how is the leachate removed? It is removed using this liner. So you see the next question. This question number 6. So this is a poll. So what are the advantages of source reduction in wasteland? So the given options are increase useful life through durability, decrease the useful life through repairability, increase the energy usage in the product manufacturing, and reduce material use in product manufacturing. So you can answer this in the chat as well as the poll. So I'll just drop a poll. You can answer question number 6 and to drop in the poll. You can also answer in the chat. But let me check the polls if someone is answering. Okay, we have one C and one D. So someone is saying take it. So we'll see the answer for the sixth question. So the question is, which of the following are the advantages of source reduction in waste management? So when we talk about source reduction, the primary aim is to increase the use of waste as a virgin material. So we want to use the waste itself in production. So that would be reducing the material using product manufacturing. So we want to mine for the material. Instead, we would recycle the waste and use it in product manufacturing. So that is one of the options. I think someone said D. So D is correct. Along with this, yeah, we don't want to decrease the useful life. That is wrong. So we want to increase the useful life through durability. That is because the more durable we make a product, as for example, if we take a mobile phone, so the mobile phone is durable. It is quite updated. We may use it for 5 6 years also. So, but nowadays what is happening is the phones are being made less durable. So within 3 years there are software and hardware issues coming up. So we will need to change the phone in that case. So by making the product durable, we can reduce the amount of products that go into the waste stream. So that is the first option, A. So both A and D are correct. Yeah, we don't want to increase the energy usage. So C is also wrong. So A and D are correct. This was a multi-correct question. So A and D both are correct. So we want to increase the useful life through durability and reduce the material used in the product manufacturing. So students can refer to week 1 lecture 4. So reduce material use in product manufacture, increase the useful life, reduce the toxicity, uh, try to reuse the materials as pellets and containers. So even the packaged material is recycled nowadays, and such as aluminum cans are used again and again. Then we have efficient consumer use of materials. See the next question, question number 7. Which of the following are the problems associated with landfill gas? So the given options are non-toxic, toxic, combustible, and odor. So when we talk about landfill gas, will have two components primarily. One will be methane, and the other one will be carbon dioxide. So methane will have a pungent odor of its own. So first problem will be that we just check. Someone is with you. So methane is a combustible gas. Okay. So C is correct. It is one of the problems in methane is combustible and it can lead to fire in a landfill. Also, methane will have an odor of its own. Will have a pungent odor. C and D both are correct. So then we have CO2. So both these gases are combustible and they use oxygen for burning. So they are also toxic in some sense. As CO2 can, what happens is when we have CO, so we take up the oxygen that is present in the atmosphere and that to convert to CO2. So that is one of the disadvantages. So they are toxic also in some terms. Both, all these three options that are B, C, and D, all three are correct. So these are the problems that are associated with landfill gas. So toxicity is there, combustion will happen, odor will also be there. So we have methane and carbon dioxide. So primary reason is that anaerobic decomposition happens, which makes these gases toxic and odor. So we'll see the next question, question number 8. Which of the following are the removal mechanisms of leachate from landfill? So we have first option that is drain by gravity, second option blowing, third option is pumping, and fourth option is siphoning. So leachate removal is done by mainly two techniques. So the first technique is drain by gravity. So we'll simply design the landfill in such a way that this is the landfill. Water seeps out from this area, water will seep out from this area. So we'll provide a slope here and we'll provide a slope on this side. So all the water will get collected here. We'll place the liner so that it does not percolate into the bottom layer. And from here we can drain it through gravity or even by pumping. So pumping is also correct. So both A and C are correct. So drain by gravity and pumping. So students can refer to first week, lecture 5. So we would want to drain as much as possible by gravity because it is cheap. You don't need to set up a pumping system. In case you are not able to drain by gravity, if the landfill layer does not have enough slope, so in that case we go for pumping. So both gravity method and pumping method are used to pump out the leachate. So next question is a poll, question number 9. So the question is, which of the following represents a negative impact associated with the incineration of municipal solid waste? So the given options are large volume reduction, air pollution, potential energy recovery, and none of the above. So can answer in the chat. I'll also drop a poll. Question number 9. Launch the poll. Answer it. I'll give you a minute maybe for this. Then we can see the answer. We have a few people who are saying air pollution. Okay. We'll just check the polls and then we'll see the answer. I think everyone is saying the correct answer. It's air pollution. So negative impact associated with incineration is air pollution. Okay, is option B. So large volume reduction happens. So that is not a negative impact, and that is a positive impact. Potential energy recovery. This is also positive impact, but negative impact would be air pollution. So how do we manage this? We will use this called as stack control. So the chimneys that are used in incinerators should have certain mechanisms, such as there will be gravity filters. Nowadays, it is necessary to provide electrostatic precipitators. Now they are also coming in automobiles. Industries have the use of this from long time, but now they are being provided in bikes and cars as well. So to filter the air before releasing it into the atmosphere, so that the toxicity of air can be reduced. So air pollution is a negative impact associated with the incineration of municipal solid waste. Option B. We'll see the answer. So you can refer to the first week, second lecture. So alternatives to landfills are incineration. So here we can see the positive. So large volume reduction happens because we are burning the waste. So it will reduce to a smaller quantity, and so we'll need less landfill space. So that is one of the advantages, and also we can recover energy. So energy will be heat and electricity. Negative impacts will be air pollution. So that is why we need to have stack control. So we'll see the next question, question 10. So this is a basic question about the definition of solid waste management. So first is comprehensive program of waste prevention, recycling, composting, and disposal. Comprehensive program of waste disposal only. Comprehensive program of waste recycling only, and none of the above. So when we talk about solid waste management, there are different stages, as I told in the overview slide. So we want to prevent the waste, we want to recycle the waste, we want to do composting, we want to do disposal. We want to take care of all these processes in single umbrella. So that is why it is called as comprehensive program, means it is combining all these two, compressing all these different processes into one process. So we want a process to have all these components. That is why it is option A. So we are not concerned with waste disposal or waste recycling. These are just stages. We are concerned with the whole process. So that is what is called as solid waste management. So correct option is A, comprehensive program of prevention, recycling, composting, and disposal. So you can refer to week 1, lecture 2. Just enter the person. Coming to the next question, it is a poll. So question 11 is, which of the following method is used to recover energy from the incineration processes? So the given options are heat, energy, cogeneration, and we have all of them. So you can answer it in the chat and also drop a poll. And answer question 11 in the chat. One said C and D. Okay, let's check the polls. C and D in the poll also and chat also. We'll see this. So which method is used to recover energy? So firstly, what we do is we recover heat. We also recover energy. So we will burn the waste refuse that is called as. So we'll subject it to high temperature. On being subjected to high temperature, we can carve out the heat, or we can also use the heat to turn a turbine or other energy production stuff. So both heat and energy are produced. And some plants will use both these techniques. So they will also harness the heat, and they will also harness they will use the heat for turning forming energy. So it will be called as cogeneration. So all these three things happen. So A, B, and C all are correct. So it will be option D. So yeah, it was a bit confusing between C and D. I would agree. So but no, you should not be confused. All these three techniques, heat, energy, and cogeneration, all these are used to recover energy. So the correct answer is option D, all of the above. So three methods we use for recovering the energy. So we have heat, electricity. So I think the option here should have been electricity instead of energy. So yeah, seems to be correct. Heat, electricity, and cogeneration, all these three we can do to recover energy. That is called as waste to energy. So we'll see the next question, that is question 12. Which of the following is the drawback of recycling waste? So the first option is save precious resources, improves the efficiency of composting, lowers the impact of mining, and can result in Superfund sites if poorly managed. So once we recycle, what happens? We need to do less mining. So the requirement for virgin materials reduces, that are materials which have been freshly mined from earth, so that can be reduced. So we'll save precious resources if we do recycling. So that is a positive aspect or a merit of recycling. That is not a drawback. Also, if we are recycling, so we can improve the efficiency of composting as well. So that also can be done. So if we are recovering organic wastes from the waste stream, so we can use them in composting. The more richer organic content we provide to the composting process, the efficiency will be better. So both A and B are positive. So as we saw, we need to do less mining. So lowers the impact of mining on the environment. So that is also a positive aspect. The last is can result in Superfund sites if poorly managed. So sir gave the example of Superfund sites. So that means that these are recycling facilities. So they were funded by, so that was called as Superfund. So this fund was basically meant to, so that the recycling facilities, they are properly managed, and the waste that is coming out of the recycling facility, that can be managed well. So but what happened was that several of these facilities were not well managed. So that resulted in environmental disasters. So that's why they were referred to as Superfund sites. So this happened in the USA. So that is a drawback. So if we don't manage the waste well, So it can result in environmental contamination. So B is the correct answer. So can result in Superfund sites if poorly managed. You can refer to week 1 lecture 4. So if we talk about waste oil recycling, newspaper de-inking, solvent and metals recycling, so this can result in contamination of soil if the solvents are not well managed. So if you are trying to recycle waste, newspaper de-inking we are doing, so as you know, the newspaper will be collected and they will be taken to process them again. So the ink will be tried to wash out from the paper. So that ink, it can go into sewage streams. So to prevent that, we need to have a proper system in place. And also we'll need a stable market for the recycled products and all these things. So yeah, that is one of the cons. So we'll go to the next question, that is question 13. The assessment of the environmental impacts associated with all stages of a product's life cycle is called. The given options are environmental impact analysis, life cycle impact method, life cycle analysis, and none of them. So when we produce a product, so let's take the example of a product. So it will concern with mining. Then there will be the production stage. Then there will be the transport stage. Then there will be the use that is done by the end consumer. Then it will go into waste. So all these different stages are there in the life cycle of a product. So the energy that is used in each of these life cycles, such as in mining, production, transport, use, waste, all these should be added. So that is the whole life cycle of this product. So we try to analyze this and we call this life cycle assessment or analysis, both you can use. So LCA it is called as. That is how we try to judge what will be the effect of a product. So what generally people say is that how much material was used, what was the cost. So, but that will not give the full picture because the full picture should contain all these stages. That is why we have worried about the environmental impacts associated with all stages of a product's life cycle. So we'll call it life cycle analysis. See. So life cycle analysis is the correct answer. We can refer to week 1, lecture 1. So here you can see life cycle assessment or analysis, both you can use, has been suggested as a way to solve waste problems. So we assess the environmental impact associated with all stages of a product's life cycle from cradle to grave. So we'll from mining stage to the when it goes to waste stream, all stages we'll analyze. So it tries to avoid a narrow outlook on the environmental concerns, and this was part of RECRA. So RECRA is just reiterate it again since it is not written here. So it is Resource Conservation and Recovery Act. So it was passed in the US, and LCA is one of the important guidelines in RECRA. So we'll see the last question of today's class. 14. Landfill liners are made from which of the following materials? So the first option is sand, clay, geomembranes, and glass. So when we talk about landfill liners, so we will use both clay and geomembranes. And there will also be a third category that will be composites. So we'll use both clay and geomembrane sync with each other. So B. So clay and geomembranes are used to make liner. So low permeability barrier layers. So clay is basically compacted soil. So we try to keep the permeability as low as possible so that the leachate cannot percolate through this layer. Geomembranes, it is a form of a polymeric material, so it is a kind of a plastic only, and then we will have composites. So we'll have multi layers of them arranged together. So this will prevent leachate from migrating out of the landfill. So now we can take some doubts if anyone has. You can type it in the chat or ask them. So that's the last question. So we can take some doubts now. You type it in the chat. You can ask it. In case you don't have any doubts, please feel free to close. So if you found the session useful, please type a yes in the chat. If you faced any issue, you can type that also. Try to take care of that in the next session. This session will be conducted every Saturday, 5 to 6, along with the other session that will be conducted on Friday, 6 to 7. You can attend any one of the sessions or both. It's up to your convenience. We'll wait for some minutes. If anyone has any doubt, you can type it or ask on the chat. So, how many of you watched the first week lectures before attending this session? Please answer in the chat. Just drop a yes. So if anyone does not have any doubts, please feel free to leave. If you have any doubts, I'm here. So type it or you can ask it directly. So if anyone does not have any doubts, if anyone has any doubts, you can ask. Or else we'll end the call in another 2 minutes. If you don't have any doubts, please feel free to leave. Yes, so I will end the call now. Thank you everyone for attending the session. We'll meet next week.